Why do some things, for example laptops, need massive power bricks, while other high-power appliances, kettles, hairdryers, don't? Electricity comes in two flavors, spicy, AC, and bland, DC. There's also two other things that are important: how fast do you want it coming in, voltage, and how much do you need, amps? When you plug into a wall outlet, you're getting spicy AC power at 120 volts in America or 230 volts in Europe, and a standard house circuit can supply 20 amps, at least in America, not sure about other places. In either case, that's the electrical equivalent of having your garden hose on full blast. It's coming out pretty good, but it's still relatively safe and usable for the average person. For big dumb things like a hairdryer or a blender that just want to go fast or get hot, this is great. Just take that full blast spicy power and go brrrrrrrr. Similarly, you could hook that full blast hose up to your lawn sprinkler and it'll work fine. If you want to run something a little more sophisticated though, like a laptop or a PlayStation, you need that bland DC power. AC power is all wiggly, DC plods along in a nice straight line, and if you want to do math with electricity, it needs to move straight. You also probably don't want it coming in so full blast. Your sprinkler may be able to handle the hose on full, but if you stuck it in your mouth, you'd probably have a problem pretty quickly. So you gotta turn the spicy AC into bland DC. That's what the power brick does. You also need to turn the hose down. It also does that and brings the voltage down from 120 or 230 to usually something like 5-12 depending on what you're running. Instead of your hose on full, it's your faucet on at a trickle. I also mentioned amps earlier. Basically, how much power do you need? Keeping with the hose analogy, how big a hose do you need? Your house circuit can supply up to 20, but you've got to filter that through the transformer in the power brick. If you're just charging your cell phone, you don't need much at all, so the dinky little block that fits in your hand is fine. If you want to run an Xbox though, you'll need more. All that math requires a lot of power, so you gotta have that much larger brick to get the same bland 5 volts. But you need 2 or 3 amps worth, and you need more space to accommodate the hardware for the additional capacity. AC is all wiggly. Best Eli5 I have read. Best explanation on this thread. That's actually. This should be the top comment. Every explanation should relate to universally relatable real-world examples. This does that. A laptop needs to convert the AC power from the plug to DC to use it. That power brick is what does that. A hairdryer uses AC, so it doesn't need to convert. The only reason it has a block on the plug at all is for its GFC protection to avoid shocking the user if it touches water. Things like kettles and hairdryers don't care about the power source very much. At their core is just some coiled wire that electricity is passed through. The resistance creates heat. Laptops need to charge the DC battery and use a lower voltage also. This plus some devices, especially larger ones, will essentially move the power brick parts into the device, such as TVs. Or, if you get a plug which is larger and boxy, that's essentially a power brick too. They all do the same basic function. The ones that have an external power brick are able to let the device itself be smaller. Just to add to it, a laptop puts the power supply converter on the cord because it's too bulky to place in the laptop, where a desktop computer still has that same power supply, but usually bigger, except it is inside the PC case. Kettles and hairdryers etc. all run directly off AC voltage. Laptops and phones, all electronics, need DC voltages. That brick is a converter that generates DC voltage from AC mains. Bigger electronic appliances like desktop computers, TVs etc. have a built-in AC-DC converter, so they don't have a separate brick. My TV has an external power brick. I've also seen monitors with both integrated and external power supplies. There are also some smaller forms PCs that can run with external power bricks. Kettles, hairdryers, etc. use power mainly for heating or to run a motor. These things can take the full mains voltage and does not need any form of power conversion. However, things that use transistors and other semiconductor devices to run logic circuits need a very low voltage. Similarly with batteries, as each battery only have a small voltage across it. This means that these devices needs to transform the main voltages of about 120 V to 240 V into eventually something like 3.3 V or lower, however usually with an intermediary voltage of maybe 12 V or 20 V. This is what the big power brick does. It transforms the higher mains voltage into this intermediary voltage that can then more easily be converted to the correct voltages. The size of the power brick is roughly proportional to how much power it can transform. So something which draws just a tiny bit of power like a control chip in a device, or for example an LED light, might have a tiny power transformer built into it, but a larger device like a laptop or a TV need a larger external device. Things like hairdryers don't care too much about what electricity is given to them. So long as it's close enough, they'll work just fine. But things like laptops are more sensitive. They need the electricity to be just right in order to function properly. The power brick takes the electricity from the wall and makes sure the laptop can use it safely. Nearly all electronic devices use DC power internally. Many of the components that make computers possible, especially transistors, require electrons to move in a single direction. This is because logic gates work by turning the flow of electricity on and off very quickly, much faster than AC power oscillates. Some components, like memory cells, also need continuous power to maintain their state. If the electric power inside a computer was constantly turning on and off, which is what's happening in an AC world, then the computer would not be able to maintain its state, pretty much making it useless. First, let's think about electricity as if it were water moving in a pipe. There are two types of electricity: alternating current, where water basically sloshes back and forth from the pipe, and direct current, that's like a stream coming from a hose. Well, kettles, and other appliances that make heat, only need the water to move. Friction of the movement makes heat, thus kettle work. It doesn't really matter if the movement is in the same direction, or back and forth, and it tend to be sturdy, so the pressure of the water and its speed is not going to cause much issue. Maybe it will heat a bit faster or slower, that's not the end of the world. Hairdryers are the same thing as far as heating goes, however the motor responsible for moving the air is a clever thing, as it can act both as a bike pump where the pump handle is pushed by the back and forth sloshing water, or it can act as a water wheel turning the propeller that's in it, so it also doesn't care much about the peculiarities of electricity, as long as it gets it. Computers and other electronics, on the other hand, are extremely delicate, and only work with water flowing in one direction like out of a hose, with part in the processor as thin as the human hair. Now in pipes that thin, it's not exactly hard to break stuff by putting too much pressure, or putting too much water through it. So the power brick sits there to act as a pressure regulator, that doesn't allow water in with too much pressure, thus preventing damage, and to make sure that water's movement will be a nice even stream, not the sloshing back and forth type affair. A hairdryer and kettle both do one big thing: take a lot of energy and turn it into heat. A laptop does a lot of tiny little things and therefore can't take big power, it needs a whole lot of little power. Shrinking the power down generates some heat, and since it doesn't have to be part of the laptop, which makes it more portable. Looking at the other responses, I see there is a focus on the fact that most power bricks, or wall warts if you want an older term, convert to DC. I disassembled a hairdryer, and it had some diodes inside to convert the AC to DC to run the motor. Those power bricks are also lowering the voltage to a consistent level. If you look at the label on most power bricks, they have a range that includes 240 and 120 volt. In the past, those power bricks would have to match the voltage available in your particular country, but most work internationally. It's easier to get a nice and steady 19-volt DC than it is to get a nice and steady AC voltage from a transformer. Be careful if you take that hairdryer or waffle iron traveling. Laptops usually do not have their power supply unit built in, as that would add to the weight of it and would make them run hotter, as SUs require ventilation. That's what the power brick does, it fills the role of the power supply unit SU, converting the AC current of the outlets in current that is usable by the system. If laptops had their SUs built in, a power brick would not be required, but laptops as whole would be quite a bit bulkier and heavier. A power brick is a bit like the transmission in a car. The transmission is there to modify the speed torque of the engine so that the wheels can spin at different speed and torque than the engine. The power brick does that. It converts the power coming from the wall into a different kind of power that's suitable for the device. Some devices don't need this, because they were designed to work with the power coming straight from the wall as it is. Simpler appliances like old light bulbs, kettles, hairdryers, and others that have been around for nearly 100 years, are the ones that the power grid was designed for in the first place. The power grid supplies a high voltage alternating current that flows back and forth constantly, and this is perfect for these basic appliances. Newer, more complex things like computers and routers work with transistors which need DC current that only flows in one direction, and much lower voltages, otherwise they just melt from the heat. This is a very different kind of power than the alternating high voltage coming from the wall. So you have a power brick that transforms one into the other. The more power it needs to convert, the bigger it needs to be, as the components inside are also bigger and tougher. An iPhone charger can be so small because the phone only needs a little bit of power. A laptop needs more, which is why its power brick is bigger. That said, nowadays, even basic appliances like washing machines and fridges will have a power brick inside of them. While the heavy-duty stuff, the motors, use the high-voltage alternating current from the wall, they also have little computers inside that need small voltages. So they're a kind of hybrid, using both kinds of current.